So let's look at why you cannot do this one with substitution. We're interested in the indefinite integral of x to the fourth plus 3 raised to the 10th power dx. And the natural thing you'd want to do is you'd want to say, let's do a substitution. W is equal to x to the fourth plus 3. So that would mean dw dx is equal to 4x cubed. Now remember here, I have to solve for dx. And when I do, if I cross multiply, I'm going to get dw is equal to 4x cubed dx. So dw divided by 4x cubed is equal to dx. So now if I go to plug in the pieces of what I'm trying to work with, I'm going to have, w become, or x to the fourth plus cubed becomes w, which means this will be the indefinite integral of w to the 10th, but dx becomes dw over 4x cubed. And now I'm really stuck. Because first of all, to even start off with, my variables are mismatched. I have things in terms of w and things in terms of x. And there's nothing that cancels. So substitution only helps if after you do all of the substitution process, you end up with a nice clean integral that only involves your substitution variable. In other words, this 4x cubed wouldn't have to cancel out with something for me to be in a better place. And since it doesn't, I'm pretty much stuck. So substitution works great if it works, but you can't force it. And to do this one, the only way to do it is just to bite the bullet with algebra and expand it out. At that point, you'd probably use a computer for it, and you might as well just use a computer for the entire antiderivative.